啊，对，男一样。你或者上面有专门的。我说为什么？我昨天跟你说那个 reference 难做，是因为它每一个不同的那个，每一个那个。就那个 soft type， 就是都是那个 soft type 都是不一样的。比如说从 news 上是不一样的，然后把那个直接把那个 newspaper 那个名字写上，然后多少符号那个，还有专门的那个 in text notation， 还有那个也没必要加那个 in text notation。
对，我就是要在几个里面讲，可以网站的节奏。
Yeah, I think we can start with the module on forecasting. It will be lots of hands-on work, lots of in the classroom e-views programming, and well, as you can see, besides the classes, there will be a test on Friday, which will basically be me giving you a series that I ask you to forecast. Then some group presentations, which will be, again, a group of you choosing a series and making a presentation about the forecast. And then 60% of the grade comes from an individual project. Individual in the sense that you have to do it by yourself, completely by yourself, where you choose yourself the series and you kind of make the forecast all by yourself and write a little report, and we will discuss these reports a bit later. So 20%, 20%, 40%, all very concentrated, but it's fairly straightforward. Basically, we're going to go through a specific recipe on how to forecast, and then you have to make little changes depending on the specific series and the specific characteristics of the series you have. Okay. No questions? Then let's start with the goal. The goal, well, to make you good forecasters in a couple of days, which will consist of, well, getting some data from the internet, putting it into e-views, then kind of go through a couple of programs to try to figure out what is the best way to forecast the series, then forecast the series and explain your forecast to your audience. That's basically the kind of the scheme for the coming days and for the coming classes. Have it up. So let's start with getting the data. Well, start going to Fred. So open your computer, open your web browser, and let's try to download some data from Fred. Fred should be looking like this. Not sure. Then, okay. So let's. Once you're in Fred, as you can see, download, graph, track 577,000 US and international time series, 87 different sources. So there's lots of information, lots of data series. The in-class exercises will all come from Fred. The test will come from Fred. But for the series, for the presentation, and for the individual work, you're asked to find series somewhere else than from Fred. Right? But this is kind of, in general, if you need some macroeconomic series, not only for the US, also the UK, China, whatever, you can find many things here. Easy to find things. For example, let's find well, we can search here or here. Monthly retail sales. And if you type monthly retail sales, you get about 3,599 series. You can just scroll down. Nice thing. You can find different series with different units, seasonally adjusted or not seasonally adjusted. We are typically going to work with not seasonally adjusted series, which then you will be asked to seasonally adjust. Okay, now let's go for something more specific. Let's find retail and food services sales. Retail and food services sales. Still have 41 series. Have series excluding something, total, not total, excluding one thing, excluding another thing, and so on. Let's go for the advanced retail sales. Retail and food services total. And we're going to look at the millions of dollars, not seasonally adjusted. Okay? So not seasonally adjusted. And then you click on this one. Let's get something like this. Here, this is the code name of the series. So you get the official name, then you get an abbreviation that can be used for, well, if you download it, that will be the title of the file. Right? Well, you can see it's the units, important to know, millions of dollars, not seasonally adjusted. Frequency, it's monthly. In a minute we're going to change the frequency, but the starting point is a monthly frequency. You can, well, look at the whole series nicely too. You can browse, you can kind of go over them and see the individual values for a given month. You can include only 1 year of data, 5 years of data, 10 years of data, and you can also indicate which time period you would like to have if you want to be more specific. If you look at the series, anything that's striking?
Seasonal.
Seasonal. Can you see always the spike? I think the spike is in December. Let's see where the spike is. December 1992, December 1994, December 1995. Makes sense, no? Yeah, we have the Christmas and the New Year effect in the retail and food service. Anything else? Indeed, it goes up. Another thing that's, so there's a trend, goes up. Goes like a cycle, another thing. So those are the things that we will be looking at. And if you would think about what is the most important part of the series, what drives, I mean, the evolution of this series. Basically, that's a trend. Maybe you see well, just forecasting the next step based on the trend will already go a long way. Huh? So that's the first thing we will do. The first thing we will look at, what is the trend? In most series, the trend determines 90% of your forecast. Huh? Then, so first step, trend. Second step is these spikes here, seasonality. The third step will be cyclicality. And the idea is that once you take into account the trend, once you take into account the seasonality and the cycles, what remains is idiosyncratic. So it's random. It's specific to the specific time and the specific series. Very important here, we are going to concentrate on forecasts that are based only on past information of the series itself. So we're going to forecast this series based on the past of this series. We're not going to use other information. No? So here we're going to forecast food and retail sales based on the past of this series. Now if you think about it, does that make sense or not? No?
No, you think there'll be other factors like inflation, GDP.
It's kind of, you could say, okay, let's take into account additional factors. So basically here we have kind of, we're going to, if you think about it, regress y on yt minus 1, yt minus 2 and so on. And some dummies. But you could say, and kind of the modern trend is, let's include some Google searches. We're not going to do this in this class. Maybe if we have a little bit of time, I will talk a little bit about it. But the standard thing is, we're just going to use the past of the series to kind of predict the future of the series. We're not going to include kind of exogenous information in some way, extra information, other than the trend and your seasonality. So let's play a bit with these graphs. Edit the graph. Well, let's first the time period. Here to 2017, you can go to 2015, whatever you want. I think the data I used in the example was till October 2017. 2017, and then I take October. I want to take up to October 2017. So let's check this. Also, kind of on the learning page, there are very detailed lecture notes. Kind of Bob Reed made very detailed lecture notes. I updated them. You can find them there. You can follow them there. To be able to replicate those things, you have to make sure that you use the same data set. So the first thing, if you cannot replicate these lecture notes, is look at the data set. Is your data set spanning the same time period? If it's not spanning the same time periods, it's unlikely you will get the same result.
Why does the October one come up with the 9th month?
September.
End of September.
Let's see what happens if you November. Do we still have October? Yeah. Well, you can also just do it like this. When I did it, and if you look at the notes, I did 10, 0, 1, and it automatically goes back. But we will download the series in a moment and see what the last number is. So first thing, you can easily play with these dates. Then let's edit the graph. So if you look at the frequency, we have monthly data. What we could say is, let's look at annual data. So it aggregates months and looks just at the averages. Now let's look at the picture. What do you see? Something much smoother. By taking the average, what do we get rid of?
Seasonality.
No seasonality anymore. No, it's kind of the average over the whole year. So the seasonal effects are gone. The cyclical effects, that will be also very short run, are also gone. So basically, if you just look at this yearly series, what do we get? We get the trend. It gives us basically the trend. So just by changing the frequency and computing the average for a given year, you basically get the trend. Any questions so far? You can see kind of, okay, easily to do, search, choose a specific series, study a bit what you have, change the time period as you want, change the frequency as you want. Next step, let's download it. Now let's go back to monthly data. make sure that we have the right time period. And then let's download the data in Excel. So do this because these are the data set that we're going to use now throughout the class. So it's with retail sales for retail and food services, total amount, millions of dollars, not seasonally adjusted. So you should get something like this. If you open this Excel file, you have first some information about where you got the data from. And then the series itself. If you have your Excel file, get rid of all this information here until line 11. When we put this data into eViews, we don't need this kind of information. We just want to have the title of the series and the data itself. That's the only thing that we need in eViews. So first step, choose series. Second step, get the data in Excel, clean it so that you only have the relevant information to be uploaded in Excel. Okay, once you did that, get it into eViews. Well, check what is your last observation. Mine would be this one.
I got 4231111.
You didn't. You should move your time series to include November. So go back to Fred. You see it's here 01.
Oh, okay, sorry, that's my bad.
0901. Then try to see what happens if you add November to it.
What's your first date?
My first date is 920101. Add to November to get it. Because it depends on which specific date you clicked on it.
That's different. I got like 476901.
Okay, that's 4769. Okay. So the last amount is a little bit different, but that just just depends on the specific time when you download the series. I did a couple of weeks ago, I think. It shouldn't match. It shouldn't matter much. Okay. So now get us into eViews. You open your eViews. You probably, if you don't remember how to open eViews, go to remote desktop connection. If you don't find that in your computer, just say here, right here, remote desktop. You should be able to find it. And then you just log in. Get there.
NetLab 这样。
Then you open your file. It's a foreign file. It's an Excel file. It's not an eViews file. So open your file. Next. Finish. I I never connect them. There you go. So now let's make sure everybody gets here. We got the series in Fred, downloaded it, got rid of the information we don't need in the Excel file, load it up in eViews. And this should be familiar. This is the abbreviation of our specific series. Retail, sales, and food, seasonally not adjusted.
How do you like get that?
I'm just gonna, okay. No, okay. File, cancel this. File, import from file, and then go to the file. So it's a foreign data. You have to import it as a file. Import from file, and then find it wherever you have saved it.
Next. Sure, next.
好像是一个
Save it.
为啥我这是紫色的呀？我这俩是紫色的，粉色的，
我看是它在
黑的。
对啊，
你这是黄色呀？那我这是粉色的，背景颜色。怎么可能看不出来？我怎么看出来两个？哎，我能看到这是黄色，这肯定是粉色。你自己看，这肯定不是黄色。
是粉色。
咋会是粉色呢？
It comes up when you've got it open
you opened
on the
it.
desktop as well.
Okay, close it on your desktop.
为啥我上面这 command 没了？
你给它删了吧？
咋删了？
You have it
你
or
点了叉。
have it?
你没有啊？咋搞回来？
那我不知道啊。
这什么鬼玩意儿？好难用啊！
Okay, we need to delete that stuff first. Okay. You have it or? It's just still down there.
It's like why the background is pink?
What?
Is it pink?
I don't know.
Supposed to be red. And
But as you see, I think it's linked. It's the series, no? Maybe this is the thing you imported.
and also accidentally like close the command window.
So here's kind of window, and then a cascade.
Yes.
And you can see which one you have. Okay, the window. Then I can arrange display. Okay, there you have it.
Is it?
That's there you have it.
Ah. Okay. Wow, 没有事好多。
Okay, since we are going to work with standard programs, the first that we're going to do is we're going to rename our series. So that we always rename it to the same thing, so that we can just play that program and it will recognize that series. If we use our program and didn't change that name to a specific name, it's not going to work. Or you have to then just change the program and tell the program that this is the series you're working with. So we always, the first step we're going to do is say, let's rename this. Rename. You left or right click on data series, say rename, and rename it into data. Because the program is written for the series data. And just say okay. From now on we have the series data, and our program is written for that specific series, whatever is the content of that data. So to see this data, let's click on the data. Those are the data. Goes from 1992 till 2017, and you can play with your windows to see the whole thing. The last one is 2017, the 10th month. Important here, you see this, M10, M9, M08. It gives you an indication of which month of data you're looking at. This is important because later we're going to use these things to create seasonal dummies. In this case, we're going to have monthly dummies. No? We're going to include dummies for each month to capture any month effect. Come back to that later. If you would have quarterly data, you would not include data for each month, dummies for each month, because you only have a dummy for each quarter. If you want to graph the series, you can do view a graph, and then make a line graph, and then there you go. This graph, so it's basically a view, graph, and then choose a line graph. So view, graph, and then we say line graph. Line. And this should look familiar. This is basically the same graph we had in Fred. Now we see our trend, we see our seasonality, we see our cyclicality, and we see this kind of bump here around the crisis. Okay, next step is we're going to create some programs. Of course, if you remember from before, you can just write things here, no? You just can write things in the comment window. Do one comment, then a second comment, and so on. The nice thing about a program is you can write all your programs and then execute them all at the same time. Okay? So we'll do File, New, Program. File, New Program. And I will open a little box. Here you have your program. So here you can now write things that make your program, and then you have here run to run the program. So now the good thing about these programs is, rather than asking you to program everything yourself, Bob at some point made lots of programs for us. So if you now go to Learn, you can find the programs you need. Let's go to Learn. Go to the fourth module. And see the kind of program. We have a practice program, and then we have step 1, step 2, step 3, and step 4. So forecasting a series will be doing that. Will be first to step 1, then step 2, step 3, and step 4 to give you the result. We have 4 pre-written programs that we will execute one by one. Important. We might have to modify them a little bit. Depending on the result of step 1, we might have to modify 2 a bit. And depending on the findings of step 2, we might have to modify number 3 a bit. But the basic framework will be in these 4 files. The first file we're going to look at is this one. So download practice program. Get something like this. So we have a long program. series here contains like 3 different parts. And so we will go through them and see what this program actually is doing. First thing, sample at all. Say, for our sample, let's use all the observations. So this is all observations. You could put a specific number here, and later on we will kind of change which observation we use, but as a starting point, we typically use all the observations. Okay? Next, okay, let's make a figure, call it figure 1, using data and make a line graph. So basically kind of make a line graph of the data. And this is why it's so important to always call your series data. Because if you don't call your series data, it will try to look for where is data and will not find it. So that's why first step always rename your series into data. Because then you can easily use these programs. Okay, so this will create a line graph of our data. Basically will give us what we already had, the series of the retail sales. And then we can kind of manipulate our graph a bit. We can say, okay, let's add the text. Basically T is for the title. This is the title. Make the title of our graph retail and food services. Oh, and this is retail and food services is still here. That's the whole title. Of course, in our case, we should change this because it's a bit different. You might want to change this to the correct one because our series goes till 2017. And then we can also add the legend. We can say, okay, figure 1, here we call it figure 1. We say, okay, put this data line into figure 1. Now for figure 1, add text to figure 1. Add text, figure 1. Here the title, here on the left, put sales. Below, put a time. So left, below. If anybody knows what this is, I don't. I tried to find it out, but couldn't find what this means. So just forget about that. Here, this one also not very important. It's just to kind of to turn it off, on and off the legend in the left top corner. Again, not very important.
But do we delete this? Or?
You can delete. Well, you can leave it there. It's not doing anything bad either. Just leave it. But
Okay.
I don't. When I deleted it, I didn't see anything different. So maybe I just didn't see it. But if you change this from off to on, you will see a difference. But again, it's not a crucial thing. So this is just an example of, okay, if you want to have a little program that adds a title to your specific series, well, this is what you could do. You say, take all the observations, freeze a figure, and then manipulate this figure. Add a title, add some text to the left, add some text below, and so on. And we will see, well, you could, now what you can do is copy this thing, copy this information in your program. Remember in eViews, well, we can copy the thing. Here we copy that stuff into your program. So that's a nice thing here. You have your Word file, and that's your starting point. From there, you're going to copy and paste things. So let's then just run the program. Say OK. And see where we can find our work file. And now something this has appeared on your work file. So once you run your program, You should, in your work file, you should find it here, figure 1. Remember, that's what we created. We said, let's create figure 1. If you click on it, oh, look how beautiful. We have our series. It has retail food and sales here, time here. It is exactly what we wanted it to do. So now, well, you probably don't have this here. You don't have the right. You probably have 2014 here.
Yeah.
Okay, now
15.
change it so you get 2017. Change your program in such a way that you get the correct title. Just change your text here and run it again. It might say that figure 1 already exists. Well, then first delete figure 1 before you run. Success?
Yeah.
So this is what you'll have to do. You find your series, download it in reviews, look at the programs you have, and just change what needs to be changed. And your series will not be the retail and food services sales. It will be a different sales. So if you want to make a graph, well, put your title there. If you want something different text on the left or on the right, well, put some different information there. If anybody has a question, please let me know. If everybody was able to do this, let's move forward. Everybody was able to do this? No problems?
Yep.
Okay, let's do some estimation of an equation. Okay, let's do some regression. Let's create an equation called trend. Basically, we're going to create the equation. And then let's put the results in a table. What do we put in table 1a? Well, trend, that's the name of the equation. LS, least squares. Let's do a least squares regression. This is the name, call it trend. And what are we going to regress? We're going to regress data. That's the name of our series. Again, that's why it's so important to change your series name to data. Because in this program, it will work with data. We have this is y, we have our constant term, and at trend. At trend is a variable. Variable for the first observation will be 1, second 2, 3, till n. That's a trend. Basically, every month you get 1 extra. So for example, we can say every month we're going to have 5% extra. Every month we're going to have $100 extra. So add trend is just saying include a variable that looks like this. 1, 2, 3, 4, 5, 6 till, I don't know how many, we have 300 observations, so the last number will be 300. And then make a graph of the residuals in table. This will give us a graph of the residuals. In table 1b. So freeze, so basically kind of store, keep table 1a, call it table 1a, the results of your regression. In table 1b, take the graph of the residuals. So now let's use just this as a program. Copy this into your program window. So you can just do like this. Put this thing in our program.
But how about the first one?
You can keep the first one there, but later on we will put everything together. Now let's focus on this one. Let's run it. Okay, run this program. If you look at your work file, you will find two new tables, table 1a, table 1b, and also here, trend. So if you want to look what trend, if you want to see what this trend is basically your equation. Remember our equation, we called it trend. Here you see the result, the different outputs. Table 1a, we put in a table the result of our regression. We find data has a constant and at trend has a coefficient of 987. So if you look at this regression, what do you notice? Our data is retail sales in millions of dollars. What is the interpretation of C? What is the interpretation of at trend? So how do you, what are these numbers? What do these numbers tell you? What is the constant? If there is no trend, if the trend is at 0, you would have retail sales of 165,476 million. That's, if trend is 0, you get just a constant. At trend is a variable that every month increases by 1. So what does 987 mean? It means every additional month increases sales by 987 million. So the difference between this month and the next month, based on this regression, will be expected to be basically $1 billion. Very significant. R squared, 92%. What does this mean? How do you interpret your R squared? Econometrics. What's the meaning of R squared? What is the share in variation in Y that can be explained by our model? Basically by variation in the trend. So basically, this variable alone, the trend variable alone, explains 92%, 93% almost, of the variation in our series of sales. Which again shows how important this trend is, no? 92% of the variation in sales is just determined by one variable, or can just be explained by one variable. in fact, if you look at the data, it's not very surprising, no? If you look at this series, what dominates the variations here? Well, just time, just the time trend. That's why this trend is so important. That alone explains 90% of your variation. In most cases, trend is going to be very important. Not always, but in most cases as well. Now let's look at the other table. We have our work file. Let's now look at table 1b. Here we go. Table 1b, which we also created, basically was a graph of the residuals. See, graph of the residuals. Here we have our fitted line. You see, our fitted line goes up by 987 millions every time. See, from one month to another, we always increase by the same amount. That's why our fitted line is so nice and linear. The actual is around it. Residuals are here. Importance of trend. Again, it's nice, the program does this all for us. Next step. If you now look at the residuals, what is the next thing that is important? Well, if you look at the variation in our residuals, what is the important driver here of our residuals? Oh, you see all these spikes now. So the next step we want to get rid of is these spikes. Basically, this is our month of December effect. So how do we get rid of a month of December effect? Well, let's include some dummies. Let's include dummies for specific months. That's what the next thing does. What the next step in our program does. We say now, okay, let's create a new equation. Trend and seasonality. Well, we're going to again put the output in a table. We're going to do least squares. We still have the same series, we still have a constant, we still have a trend, but now add 11 dummies. This one is dummy for M1, basically for January. This one would be a dummy for M11, so for November. And then again, let's create another table with the residuals. Okay. Why do we include 11 dummies here? Why not 12? We have, after all, we have 12 months, no? Not 11 months. So why do we include only 11 dummies? What will happen to the 12th dummy?
It will be the same with the previous one?
It will be the same with what?
Previous, like the...
If you will include 12 dummies, then we would have perfect multicollinearity with the constant term. So it will be perfectly the same with the constant term. Because the sum of your 12 dummies would be 1, 1, 1, 1, 1, 1, 1, 1 everywhere. Right? So as a consequence, what we're going to do is we're going to say, drop 1 dummy, basically the one for December. And what will be the consequence? Our constant term will be December. our constant term will be December, and the coefficients of all these dummies will show how a given month is different from December. So now let's copy that and put it into a program and see what happens if we run it. Can again delete what was there. Run it. Okay. See the result. We should have table 2A and table 2B. So we put we have a program, we copy our text from Word into our program and just run it. Result, table 2A, hoo-ha. What do we see? Well, we have again regression of data on a constant term, on our trend variable, and on seasonal dummies. What's the interpretation of C? Well, if all these things are 0, this is what we will have. So basically, if there is no trend, basically we're in the period number 0, and all these dummies will be 0. Basically, if all the monthly dummies are 0, we are in December. In December of the initial period, we will have sales of 215,475 million. Okay, now how do we interpret this one? The coefficient of season 1, the coefficient of January. Basically, compared to the constant, compared to December, in January there will always be $81,000 million less sales. In February, minus 82 million, compared to December. So very important, these numbers you always compare to December. Because we drop December, December becomes the benchmark. How does January compare to December? How does November compare to December? Now look at your R squared. 97.7. 97.7% of the variation in our data, the variation in sales, is determined by trend and seasonality. And in fact, we can look at table 2B. Well, now fitted is no longer a straight line. It's the straight line plus your seasonal effect. You see, every year we have the same effect. The change in the months. If you now look here, what is still here? The residuals. Well, we don't see a clear seasonal effect here anymore. No? We don't see the seasonal effect anymore. In fact, if you now compare the true and the fit, they're very close together already. No? Basically, trend and seasonality explain 97% of the variation in the red line, in your actuals. So this is why in our program, the first thing we will do is try to explain the trend. The second thing we will do is try to explain seasonality. Why? Because these are typically the two important things. Next one will be the cycles, basically the correlation across time in the errors. So that's for later. Okay? Okay. Now, before we take a little break, close E-views. close eViews, restart it again, load in your Excel file, and run the whole program at once. Not one piece by piece, but just copy the whole program, run it, and you will get all these tables at the same time. See whether you can do that. If you can do that, you're already halfway this class. Once you're finished, you can take a 5 minutes break.
一步一步的，这也是那个。这样吗？你忘了吗？哎，你俩忘了？
没忘了。
要一步一步来，是不是？ So we can't like do all the
Yes,
that comment.
copy the whole thing and put it in there.
But it doesn't
yes.
allow to run.
Data is not.
First
step.
Right,
First
right.
step.
Yeah.
Don't forget to rename your series into data. If you don't rename your series into data, it won't work. But it will tell you why it doesn't work. It will tell you, I don't know data.
Right. 看你最后这个，不是这个东西，
不一样吗？
不一样。
不是哪个？
让我重新开一下。
不是你是找 table 吗？这个。是的。
一样，其实一样。但刚才显示不是，它为什么要去掉那个词？为什么去掉这个 residual 的声呢？
我真没看，他怎么说呢？就去掉 residual。
在去掉 residual personality 的一个性质，然后这个 fit 就和 residual 是，fit 就和那个和 actual 就是一样的，就是很相近。I don't get it. Like, why we should get rid of the personality for residuals?
Okay, general question. Why should we get rid of our seasonality?
For residuals.
We're trying to forecast that.
We're going to try to forecast. We're not trying to get rid of them. We're trying to see what is the effect of that. So what is the effect of the fact that we're in January? Because if we forecast January, we want to then add the January effect. See, so that's why here we're first doing a regression equation and try to get as little as possible in the residuals. Because the residuals is what we can't explain. That will basically be our forecast error. So ideally, we get to residuals are all 0. It means we are perfectly able to forecast our series.
Okay.
At least within our data set. So that's why we're not really getting rid of anything, we're just trying to see what is the effect of that specific factor. What is the effect of the trend? What is the effect of being in January? What is the effect of being in February? What is the effect of being in December? Because later we will predict for, say, November. So we have to add the November effect in.
因为它这个
想要知道真正的，但是有 seasonality 的时候，你不知道真正的。
不是，因为如果是这样的话，如果是 residual 的是这种情况下，这个是 residual 跟 seasonality 同时作用于它的 actual， 就是咱们要 get rid of 的，就是去掉这个 seasonality 这个情况。我知道，就是不考虑这个 residual 情况，只考虑这个，不考虑 seasonality， 只考虑 residual。
考虑真正的
residual， 对 residual。那这 fitted 是咱们预测的是吧？这三个项目三片。
Yes, yes, yes.
Another question. What about this very nice
Actual?
Yeah. It's like
The series we have, we start with. Fitted, predicted. Residual is the difference. The difference between those two is this. You see the difference here is a lot.
So the fitted line is what we
Predict. Basically you have y is alpha plus beta times x plus eta. So alpha plus beta times x, that's fitted. Eta is residual, y is actual. So this is y, beta plus beta x, these are your x's, this is eta.
So it's xy.
Well, depending on what it is. I don't think I cannot write this. So I cannot write it. So this is y, beta plus beta 2 times x plus beta 3 times x2, 3 and so on, all the x's, plus eta residual. This is sum of these.
Sure, he's you know the sword. Okay, let's continue. So now, so far we just did a little practice program. Kind of a little program to show what it means writing a program in eViews. What kind of things you can do. Now we're going to look at the 4 different programs that we have to go through, the 4 different steps we have to go through when we actually make a forecast of a series. So the first thing we're going to discuss is, we're going to discuss the trend. This is about a trend. We want to see, is the trend in logs or linear? What is the difference? Linear is plus an amount. Every month you get $980 extra, or $980 million extra. That was a linear trend. A log trend would be plus a percentage. Every month we're going to add 5%. So you see the difference, no? You can have different kinds of trends. You can have a trend where every month you add the same amount, or every month you add the same percentage. That will give different trends. This will be linear, this will be more exponential. Right here. We have a fixed growth percentage. So basically we get an exponential. If your series looks like this, then you don't have a linear trend. If your series looks like this, that's a linear trend. So here we have more something like this, or it could be like that, but this one is linear trend. If we looked at this one, for example, here it's clear, you see, this is a linear trend. It's fairly clear now. Not a logarithmic trend. But rather than kind of doing eyeball tests and just look at the graph, we're going to look at some more formal testing of that. So first, we're going to decide whether the trend is log or linear. Once we decided on that, we're going to check whether we want to have a trend and seasonality terms or not. So basically check for the seasonality. Then we're going to look at cyclical terms. Basically this will be MA, moving average terms, of autoregressive terms. So moving average or autoregressive terms. And once we decided about these three elements, we will actually make our forecast. So basically, once we know the coefficients of these elements, once we have an estimate for these coefficients, so coefficients are estimated, then we can go to forecast. First, estimate. Here we have estimation. Here we have forecast. So we will have 4 different programs. The first program will try to figure out whether we have a logarithmic or a linear trend. The second step will try to see whether we have to add seasonal issues or not. Third one will look at whether we have to add MA or AR terms. And then once we have run through these 3 programs and made a decision about what is our best specification, we're going to take the best specification and use the best specification to make a forecast. Right? And we will define in a minute what it means, the best specification. So now go to Learn and download Step 1 program. And you will see it looks something like this. This is the first program that you have to run. Important again, you will work with the series data. So make sure that your series is called data. Let's now look at this program and try to understand what it means. This is, let's use all observations. Let me say, generate a new variable at trend. So before we included at trend straight in the regression. Now we say, okay, let's create a new variable at trend. So let me show you how that one will look like. Well, we can do here, generate time is at trend. Now go back to my work file. I made it time variable. Time variables. It's a trend. Starts with 0, 1, 2, 3, 4, 5, always 1 extra. Clearly a trend. Now rather than including at trend, we can also include just this variable. Nothing special here, just define the variable. Okay, so now let's define some equations. First equation says, let's do a logarithmic transformation of our series. Why? Because we want to see whether the trend is logarithmic or not. So here we say, we go into regression, the log of